Alright, let's combine stoichiometry with some molarity business. How many milliliters of a 0.345 molar phosphoric acid solution are required to neutralize 125 milliliters of a 0.123 molar KOH solution? Well, key word here, neutralize. Remember, neutralize, react. These are all things that tell us, hey, I need a balanced equation. So phosphoric acid, remember, is H3PO4, and it's going to react with potassium hydroxide. What are we going to make? Oh, we're going to make some potassium phosphate and some water. Now, potassium forms a +1 ion, phosphate's -3, so I know it's K3PO4. And when hydrogen teams up with hydroxide, we make HOH, or remember, this is H2O. So I need to balance this up. I got 3 potassiums. I think I need 3 potassiums. And let's see, that's going to need 3 hydroxides. So I'm going to go ahead and put a 3 here for the 3 hydroxides. 3 hydrogens, 3 hydrogens. Good. Okay, so it's balanced. 3 there too. So now we know the units of my answer. Well, how many milliliters of phosphoric acid solution? So I know the units of my answer. I'll put over here. Milliliters of what? Phosphoric acid solution. Okay. Well, I only have one place to start. Remember, this isn't something per something, so I'm not going to start with something per something. So remember, this right here is molarity. Remember, molarity is moles of solute per liter of solution. So that's moles per liter. I cut that off. Moles per liter is what that italicized M is. Same with this one over here. So each of those are not what I'm going to start with. So I only have one thing I can start with. In this case, it's not. That's 125 milliliters of KOH solution. So I'm going to go ahead and write 125 milliliters KOH. Well, like all good chemists, this is a reaction, so I need to get this into moles. So I can say, look at this. I know that for every 0.123 moles of KOH, I have 1 liter of solution. I could also say, so I have 0.123 moles of KOH per liter of solution. Well, how many milliliters are in a liter? 1,000. So I could also say this is 0.123 moles KOH in 1,000 milliliters of solution. That's what I'm going to use, so I can cancel this milliliter. So I'm going to say, okay, 1,000 milliliters of solution is 0.123 moles of KOH. All right, bingo, into moles. Now I'm going to use my mole to mole ratio, and I know for every 3 moles of KOH I require 1 mole of phosphoric acid. 3 moles of potassium hydroxide on the bottom, so I cancel those guys. 1 mole of phosphoric acid. If I were to stop right now, what would be the units of my answer? Let's see, moles of phosphoric acid, but I need milliliters of phosphoric acid. So I can do one more step, because look at this. I have a concentration of phosphoric acid, 0.345 moles per liter. But just like before, I'm going to do moles per milliliter, because 0.345 moles phosphoric acid per 1,000 milliliters of solution. This whole thing here is what is incorporated with that molarity there. So let's see, I need moles on the bottom. Oop, I didn't leave much room there. So let's see. I know it's 0.345 moles of phosphoric acid. And for that phosphoric acid, what do we have? 1,000 milliliters of phosphoric acid. So now, if I cancel my units, oops, not that number, just the units, I end up with milliliters of, this should be H3PO4, and that's what we're shooting for, milliliters of phosphoric acid. So just to give myself a little bit of room, get another sheet here, and let's just do the calculation. So now I have, let's see if I can get this in my calculator here, 125 times 0.123 times, I'm not going to worry about the 1, times 1,000 times 1,000 divided by 1,000 divided by 3 divided by 0.345 equals. So the answer then is what? 14.8 milliliters. How many sig figs are we good to here? Let's check that out. What do I have? I have, wow, the camera's kind of freaked out a little bit there. All right. I have 3 sig figs, 3, looks like my answer is good to 3 significant figures. So if I do that, 14.85, that 5 is going to make the 8 and 9. So that 5 makes this 8 and 9. So 14.9. 14.9 milliliters of phosphoric acid solution.